All right, good morning, everybody. I'm sure you know that I'm not very excited that we are not in class. I do enjoy seeing everybody every day, but here we are nonetheless. We'll have a couple of lessons here today, and we will talk about states of matter and move through that again and get to the end of those notes, and then we will be done with the day. All you'll have to do is answer the questions when the video pauses, and you will be gold for today. All right, a lot of this is going to be review. I will post a link to this video as well in our Google Classroom so you can watch that. I think that would be another thing that would be very nice for some of us that may have missed it to go back and view, because this is one of our better videos. Not going to spend long on these first definitions. They will be on the quiz when we have the quiz on these vocabulary words, but it is just something that you're going to need to know when you're actually taking the test. Matter is anything has mass and takes up space, and we have learned throughout this week that solids, liquids, and gas are all three states of matter because they all have mass and they all take up space. Volume, you will hear it a lot of times. Instead of saying that something has mass and takes up space, you'll hear that it's something that has a specific volume or not a definite volume. But all solids, liquids, and gases do have volume because they do have a very specific amount of space that they take up. Now that can change. We know that when we talked about gases, that the volume is not definite. It can be moved around as far as like how much space that it takes up. And the shape, that's one of those words that's just there. We didn't even take the time to put that in our formal definitions on the anchor chart, but there it is nonetheless, because when we talk about solids have a very definite shape, we're using that word shape just in case somebody didn't understand what that meant. We went ahead and defined that as well in our notes. All right, three states of matter. Again, that's just for now. This is extremely important. We start off with a solid. I'm not going to talk about rocks. I'm going to talk about ice, because when I put this in the terms of water, it's very easy for me to understand. If I'm down here and I have ice, if I add heat energy to ice, it will go through something that we're going to learn about today called the melting point, and that ice will then turn into the liquid. Now, as we have liquid water, and we've talked about those molecules kind of moving around freely there, if you add enough heat energy, those molecules build up a lot of speed, and they actually will turn into a gas. So you can move from a solid to a liquid to a gas. Now, that's all with adding heat energy. If you do the reverse of that, if you take heat energy away from gas and you think about that water vapor that evaporated in the water cycle, as it moves up into the atmosphere, it starts to lose heat energy because it's colder, and then it would turn back into those teeny tiny little drops of liquid that we see in the sky with dust and other particles as clouds through the process of condensation. And then if you have a liquid water and you take away enough heat, it will freeze and turn back into a solid. Again, probably next week when we get here, we're going to be showing you how you can bounce from a solid all the way to a gas without going through this phase. And then we're going to try to replicate this. If not, I do have a video of it. We're going to try to replicate one from a gas straight to a solid. But again, you need to talk about adding and taking away of heat energy as you do that. And that's going to come later on in some of our notes. Very quick review of solids, which we're going to see more than once today. But solids are a form of matter. They have a definite shape and they take up a definite amount of space. And unless you've been out every day that I've taught this, you already have this in your notebook. Liquids also are a state of matter, and they take up a definite amount of space, but they don't have a definite shape. They take the shape of their container. And we even talked about how much some of us spill things on the floor in here, and then that liquid takes the shape of the floor when it's in the room. It's no longer in the shape of the bottle that it came out of. And last, we have gas. Gas does not have a definite shape. It does not take up a definite amount of space. It does take up some space. It does have volume. But again, like we talked about, even if you had like that balloon or you had the beach ball, you can kind of squeeze that and change the shape a little bit and move the gas around so it doesn't have a definite shape. And we're going to move on. We got to hear yesterday. We've drawn the pictures. I'm going to come. I know later on in the Nearpod slides, there's some better pictures that I think of the molecules of solids, liquids, and gases, but we'll come back to that as we move on. I can attach that video again if we need to. We're not going to watch the guy that we watched yesterday for solids, liquids, and gas for Discovery Education. I'm going to skip those because we already gone over that in class. Again, changes in states of matter. You're going to talk about how you go from a solid to a liquid to a gas. And I like this. I like how you can see how in a solid, the particles are very close together. In a liquid, they're moving around more. And then in gas, they're moving around very, very quickly. I think that's what the arrows are representing there, to show you that those molecules are moving around very, very fast because they've gained a lot of heat energy. Changes in matter. Before we dig into the way things can change, we got to look a little bit closer at the molecules, and I told you this was coming up. Solids. The molecules in a solid are packed extremely tightly. Now, I know this part right here seems very weird. What do you mean, Mr. Bullens, that there's a small amount of movement? If we could shrink down like Ant-Man in the Marvel movies, we would see that even at like the teeny tiny molecular state, that even the particles of a solid are still moving. We're not going to get into absolute zero or anything like that where the particles stop moving completely. It is very interesting. Maybe once we get the podcast up and rolling, somebody could dig a little bit into the world of absolute zero, where things have reached a point where the molecules stop moving, but we don't need to worry about that for our class. Just know that the molecules in a solid are tightly packed. In a liquid, you can notice that the molecules are still bumping into each other, but there's that space in between them, and they are able to move around and flow around freely. And you kind of can understand that when you think about the way that water moves and the way that water flows. And even when you're like diving into the water, like in a pool, you feel that water moving around you. And that's because the molecules have enough space in between them to move around and flow and bump into each other. But again, if we continue to add heat to this liquid, it is then going to turn into a gas where the molecules are moving like very, very quickly and very far apart. And that's something that we need to think about there. And again, we kind of can feel that when the wind is blowing against us or when we're running, we feel that there's like nothing that we see, but we feel something pushing against us. And that, again, that's like the molecules of the gas. And they are very far apart and kind of easy to move through, a lot easier even than the liquid is. We don't need to watch that, although I know you can't see, but over here to the left of the screen is Bill Nye talking about absolute zero. Maybe I'll link that in case somebody wants to watch it in our slides for today as well. All right, new vocabulary words, and you'll notice I also attached a new vocabulary sheet that has a ton of words that we're going to talk about in states of matter. But the one thing that we need to talk about is melting point. Melting should not be a new vocabulary word for anyone. Every day when I've asked you what would happen to an ice cube if I laid it on your desk, all of you said eventually it would melt. That is true. That is because it's gaining heat energy from the classroom. Even as cold as I keep it in the classroom, it's still gaining heat energy in here because it's above 32. If you leave it at 32 or below, it's not going to be able to gain any heat energy, and therefore it's not going to change. But when a solid and water, we're going to stick with water for now, but when a solid gains enough heat, it will go through a melting point where it's going to change into a liquid. With liquids, if you continue to add heat to a liquid like water, it will reach its boiling point. And when water boils, it gets to the point of evaporation. The molecules have been flowing together in a liquid state, and now they have moved so far apart that they are now turning into a gas. The boiling point. I think we all know what happens when you put water on a stove and you turn the stove on. It eventually boils, and it's going to cause the water to evaporate. Freezing point, which is something that we're going to see firsthand over the next few days. This is when a liquid becomes a solid. I know that later on today they're a little bit worried about when the liquids hit certain surfaces that it is so cold that it's going to turn into a solid, and we'll have some icy roads out there that we need to worry about. Some of that liquid, when it hits the trees and the power lines that are very cold, and it's not hot outside at all. It's 20 degrees right now looking at the computer. It is going to freeze because when water gets below 32 degrees Fahrenheit, it is going to cut into its freezing point. Again, melting and freezing, not something new to us. Boiling point, not really a new word that we need to worry about. But when we start to put these all together, I can understand how it might get a little confusing because it is a lot of vocabulary words at one time. Condensation, still not a new vocabulary word, but it is a newer vocabulary word for us. I know that you're thinking, Mr. Bowens, condensation is back with the water cycle. And it is, because condensation is cloud formation in the water cycle. But what we have to remember is once that water has evaporated off of the earth and is turned into water vapor, and it is now a gas, that gas rises up into the atmosphere because heat rises. And that gas is going to lose heat energy. As it loses heat energy, it's going to change from a gas back into a liquid, little tiny water droplets. And once that happens, you have condensation that has occurred. Condensation. Not a new word, but again, when you start just looking at it as far as states of matter, they're not going to say cloud formation in there. They might talk about the way that your mirror fogs up when you take a shower, or they might talk about the can that's outside, the cold can of soda on a hot summer day, and they may actually mention cloud formation. I mean, all of those are correct. It just depends on which one you're specifically looking at. That brings me to this triangle, which I am going to write on the board. And honestly, if I were you, I probably would just pause it here. And then you can watch the next part of the video that I'm talking about it, and you can kind of understand what I'm adding to this to make it a little bit more easy to understand, because there's some new words over here. I'm going to change deposition to desublimation. I'm going to change vaporization to evaporation, because that's kind of what we're going to call that. And I'm going to talk about some things. I like these little red arrows and blue arrows. I think I'm going to copy that today when I'm doing it on the board, because this means you're adding heat and this means you're taking heat away. And that is something that is extremely important for us to understand. All right. As we look at this triangle here, I do like the way they have the molecules shown. I did not do that in the notes that I took here. And I know that this looks ridiculously difficult, but it's really not. You have gas. I put gas up here because hot air rises. Liquid and solid down here are just where they are. If I go from a liquid to a gas, water to water vapor, I am evaporating and I am adding heat. To go from a liquid to a solid, that is water to ice, I am going through the freezing point. It's going to freeze. You need to lose a lot of heat energy in order to go from a liquid to a solid. Here, you need to gain a lot of heat energy to go from a liquid to a gas. Now, those two are fairly, I understand that. I even understand going from a solid back into a liquid, because that is when ice melts. It goes through the melting point and it turns into a liquid. And I understand when gas goes from water vapor back into, whoa, I did not mean to do that, goes back into water, and that is when you have condensation. Not a problem. These two words over here show up every once in a while. We will be able to do some experiments with these. Sometimes solids will go from a solid all the way into a gas. The very tops of mountains, sometimes you might have ice, because when the sun hits it, it doesn't even go through the liquid phase. It skips the liquid phase. Because normally you go from ice to water to gas, which makes sense. It melts, it evaporates, it's gas. Not a problem. Or the gas condenses into a liquid, and then that liquid freezes. I get that. These two are a little difficult. They don't show up as much, so don't stress them. If you add enough heat to a solid, it will sublimate into a gas. We will see that. You see that sometimes at the tops of mountains. Sometimes, and you see this in the mornings when frost forms on the window, that gas that's in the air touches that cold windshield, desublimates, loses heat, and goes into a solid. I see my timer is about out. Don't forget to smash that like button and subscribe and click the bell for the notifications. Ha ha ha. Have a great day, guys. We'll see you soon, hopefully Monday.